Okay, so we're moving on with subtraction, but this time we're going to go with mixed numbers. Mixed numbers, again, are when you combine a fraction and a whole number. So it's a mixture of both. So let's go to the warm-up. Now the warm-up is asking us to write these mixed numbers as fractions. I'm going to take a different direction with this because I think this will be more helpful. So let's pretend these are our mixed numbers that we have to subtract from one another. They both have different denominators. So the first step with these is, of course, to find a common denominator. So with the 4 and the 8, we look at those two numbers and we ask ourselves, is the bigger number a multiple of the smaller? And let's check that out. So we have 4, and we have 4, and we have 8. So yes. So in that case, then we're going to keep 8 as our common denominator for those. So let's pretend we have 1 and 3/4, then we have 1 and 5/8, and our 8 is our common denominator. So that means we're going to keep this one at the bottom, but we have to change this one to 8s. So let's keep this one. All right, so what we do is, again, just like most equivalent fractions, we just see the 4 and the 8, and we know we have to go by 2. Change that. And that gives us 1 and 6/8 and 1 and 5/8. And now we can add or subtract or do whatever we need to do. Just for the sake of practice, let's pretend we were subtracting these. The 1 subtract to 0, 6/8 minus 5/8, that gives us 1/8. So again, a lot of the same rules that we've already learned apply just with mixed numbers. Okay, so let's go to our first page, page 259. Again, if you're from home doing these notes, just pause or rewind if I go a little too fast. I try to get these videos done pretty quickly, but you have a chance to hit the pause button if you ever need to. Okay, so on Saturday, Chloe spent 3 1/4 hours at the park with her family. She then spent 1 2/3 hours riding her bike. How much longer did Chloe spend at the park than riding her bike? So we're comparing two things and trying to find the difference, which is subtraction. Um, for subtraction, the order matters. Your bigger number always goes on top. Your smaller can go on the bottom. So I'm going to split my workspace into two spots. I've got my 4 and my 3, and I have to find a common denominator. So the easiest common denominator is 3 times 4, which is 12. But let's check that. Let's check the factors of 3. So I got 3, 6, 9, 12. And for 4, I got 4, 8, 12. So I've got, looks like these are the winners right there. So what we do is we set this up the normal way. Our bigger number when we subtract goes on top. So that's 3 1/4. And we're subtracting 1 2/3. I have to change the denominators of both fractions to 12. So I'm going to write it just like this. And just to highlight this, I'm going to put a little box here. So we only have to find the numerators for both of those. The denominators are now the same, but this has got to change. 3 times 4 gave me 12. 2 times 4 gives me 8. 4 times 3 is 12. And this gives me that. So we are ready to do a problem here, though, because if you look, the numerator here is 3 and the numerator here is 8. And we can't have that. What we need to do is we need to make that numerator bigger, because you can't take 8/12 when you only have 3/12. So we have to make some more 12s. So we're going to borrow a whole number here. We're going to borrow a whole number from 3, making it 2. And remember, one whole number in this case is 12/12. So we borrow those 12/12 and add it to the 3, that gives us 15/12. So subtract your whole numbers. 2 minus 1 is 1. 15/12 minus 8/12 is 7/12. And that's 1 7/12 hours. So we'll be doing a few more practice like that, but that's basically it as far as subtracting your whole numbers. All right, let's move on to the next page. There's a couple different techniques shown here that sometimes these techniques are helpful, but they're not things that I would recommend. So for example, let's see, for these models, they're great and all, but I think they're more confusing than helpful. One thing that does make sense here, you need more 12ths to subtract 1 8/12. That's why when we borrow, it becomes 2 15/12. That helps illustrate that. And then down here, we can do regrouping and such. So, but let's just get to the questions. Again, sometimes these pages are a little more confusing than I'd like them to be. All right, look at the first set of fraction bars. Why is the last bar split into 12 pieces instead of 4 pieces? Well, we can answer that even though we didn't talk about that model, because 12 is the common denominator. Now look at the second set of fraction bars. Explain why 3 3/12 is now shown as 2 15/12. Because we borrowed 1 whole. And 1 whole equals 12/12. Just like that. Look at model. How does the regrouping of 3 3/12 is 2 15/12 help you find how much longer Chloe spent at the park than riding her bike? You have enough 12ths to subtract 1 8/12. And how much longer did Chloe spend at the park than riding her bike? We've already answered that, 1 7/12 hours. How can you use addition to check your answer? So you take your answer and then you add what you subtracted, and that equals 2 15/12, which we know is 3 3/12, also known as 3 1/4. Oops, excuse me about that. 3 1/4, which is what we start out with. Do you always need to regroup when subtract mixed numbers with unlike denominators? No, not if the numerator of the top fraction is bigger. Yep, so if that numerator on the top fraction is bigger, it should be just fine. All right. You can cross off 7, and let's turn to the next page. We've got 3 examples we're going to be doing now. All right, skip 7. All right, so what is 7 3/5 minus 9/10? So here is a case where a couple things. The second part is just a fraction. It's not a mixed number. Another thing I want to point out is you've got 5 and 10, and we know 10 is a multiple of 5. And because of that fact, we know that 10 is going to be our common denominator. So that's an easy way to do it. 7 3/5 minus 9/10, line everything up. All right, so 10 is what we're keeping. So we're just going to keep 9/10. This, on the other hand, needs a change. We need to change the 5th part to tenths, so we can actually work with that. That's times 2. So we have 7 and 6/10 minus 9/10. So again, we do a check here. Make you got your numerators of 6 and 9. 6 is smaller, so we have to borrow. And we know 1 whole is 10/10. So that makes us 16/10. So we have 6 and 7/10 is our answer. Next up, what's the difference between 2 and 5/8 and 1 and 1/4? Compared to 8/4, we know 8 is a multiple of 4. So that means 8 is going to be our common denominator. Take our bigger number, put it on top, and we subtract the smaller number. So if 8's our denominator, we don't change anything here. So we have 8 parts. This one we do have to change to 8 parts. Now that's times 2. And this one we don't have to borrow because 5 is bigger than 2. So we got 1 and 3/8. It's a pretty simple one. Last example. This last one, Charlie's practicing the long jump. His first jump is a distance of 16 5/6 feet. His second jump is a distance of 18 2/3 feet. How much longer is Charlie's second jump? Now, with word problems and subtraction, it's up to you to put the larger number up top. So we'll do that right away. 18 2/3. We know that's bigger because the whole number is bigger. And 16 5/6. We look at 3 and 6. We know 6 is a multiple of 3. So 6 is going to be our common denominator. So we keep that one. And for this one up here, we're going to change that. That gives us 4. And look what we have here. Our denominator is smaller up top, so we're going to have to borrow. I know 1 whole is 6/6. So that makes this 10/6. 17 minus 16 is 1. 10 minus 5 is 5. 6, and that will give us 1 and 5/6 feet. So letter B. All right. So there's your notes for today's lesson. Your assignment for IXL is L20. Subtract mixed numbers with unlike denominators. Obviously, you're going to rewrite those problems. They're going to show the problems horizontally. You probably want to write them vertically like we do. That first number will be up top, and then the second number, put it right below.